Assalamualaikum and hi everyone. Our selection topic in application of differentiation is analysis of function 1. So, my name is Fatin Halia Sarah and my team members are Nur Ainatul Shahira and Nur Hasha Kristina. So, let's get started. What is analysis of function? The analysis of function involves several key concepts in calculus, especially related to differentiation. This includes understanding where a function is rising or falling, known as increasing and decreasing functions, and identifying critical points, which are points where the derivative is zero or undefined, and are potential locations for local maxima or minima. The analysis also includes understanding the curvature of the graph and where it changed from concave up to concave down, referred to as concavity and inflection points. Lastly, first and second derivative tests are methods used to analyze these critical points and concavity to determine the nature of these points and interval of increase or decrease. Why we use analysis of function? There are 4 reasons. First, to understand behavior. This is show us how the function behaves, such as where it increase, decrease, or change concavity. Second, optimization. This is to find maximum and minimum values of functions, which is crucial in various fields such as economics, engineering, and science. Third, graphing. This is to accurately sketch the graph of a function, which helps in visualizing the function and understanding its properties. And lastly, application in real-world problems. This is to solve practical problems involving rates of change, optimization, and motion. There are 2 theorems that we use in analysis of function 1. First, theorem 1 is test for increasing and decreasing function. Let f be a function that is continuous on the closed interval AB and differentiable on the open interval AB. There are 3 assumptions. First, if f prime x is greater than 0 for all x in open interval AB, then f is increasing on closed interval AB. Number 2, if f prime x is less than 0 for all x in open interval AB, then f is decreasing on closed interval AB. And lastly, if f prime x is equal to 0 for all x in open interval AB, then f is constant on closed interval AB. Theorem 2. This is test for concavity. Let f be a function whose second derivative exists on an open interval I. There are 2 assumptions. First, if f second derivative of x is greater than 0 for all x in I, then the graph of f is concave upward in I. And the second one is if f second derivative of x is less than 0 for all x in I, then the graph of f is concave downward in I.
Problem statement. Given function f(x) equal to 2x cubed plus 3x squared minus 7. By using analysis of function 1 method, we're gonna find the x-intercept and y-intercept, find the critical point, find the interval where f(x) is increasing and decreasing, find the extremum points, maximum and minimum point, find the interval where f(x) is concave up or concave down, find the inflection points, and lastly, sketch the graph using above information. So let's move to the problem solving. First of all, we're gonna find x-intercept and y-intercept. To find y-intercept, as we know, if y-intercept, then the x is 0. So we just substitute 0 into the function. For the y-intercept, we got that when x is equal to 0, then y is equal to negative 7. To find the x-intercept, we just let y is equal to 0. So when we calculate, we got that x is equal to 1.1494. Next, we want to find the critical points. So first of all, we let f prime x is equal to 0, and we got that x is equal to 0 and negative 1. When x is equal to negative 1, we got that y is equal to negative 6, and when we substitute 0 into x, so we got that y is equal to negative 7. So the critical points is 0, negative 7, and negative 1, negative 6. Third, we're gonna find intervals where f(x) is increasing and decreasing. by using the value of x, we got three intervals, which are negative infinity, negative 1, negative 1, 0, and 0, positive infinity. Choose any valid value for each interval and substitute it into the test value function. So finally, we got that f(x) increasing at interval negative infinity, negative 1, 0, positive infinity, and f(x) is decreasing at interval negative 1, 0.
Besides, extremum points, maximum and minimum points. To find maximum and minimum points, we need to calculate second derivative, and the answer is 12x plus 6. Next, substitute value of x from critical point, which is 0 and negative 1. F double dash x equal to 12 multiplied with 0 plus 6. The answer is 6. 6 is more than 0. Thus, the minimum point is 0, negative 7. Double dash x equal to 12 multiplied with negative 1 plus 6 equal to negative 6. Negative 6 is less than 0. Thus, the maximum point is negative 1, negative 6. Other than that, inflection points. Let f double dash x equal to 0. 12x plus 6 equal to 0. X equal to negative half. When x equal to negative half, f negative half equal to 2 multiplied with negative half cube plus 3 multiplied with negative half square minus 7. The answer is negative 30 over 2. The inflection point is negative half, negative 13 over 2. Intervals where f(x) is concave up or concave down. Second derivative is equal to 0. 12x plus 6 equal to 0. In inflection point, we know that x is equal to negative half. So, in the schedule below, for interval, the first row is negative infinity, negative half. For the test value, we need to substitute it into 12x plus 6, and the value is between negative infinity, negative half. The value is negative 2. The sign of the value is negative. The second row is negative half, positive infinity. The test value is 1. The sign of the answer is positive, as the sign of answer for negative infinity and negative half is equal to negative. It is less than 0. This means negative infinity, negative half is concave down. For negative half, positive infinity is more than 0. Thus, it is concave up. The graph shows that the information we calculate before, which is x-intercept, y-intercept, critical point or maximum and minimum points, and inflection points. We also can see it is concave up and concave down, and the interval is decreasing interval or increasing interval. In conclusion, to summarize, by using analysis of function 1, we were able to identify all kinds of analysis of function that involving increasing, decreasing, critical point, concavity, and inflection point of a function. Moreover, we also could understand basic concepts and definitions concerning relative extrema, first and second derivative tests. Lastly, we use MAT183 solution to sketch the graph for our presentation video task. Thank you.